today's very special day. All of you, I know you're waiting until this moment to learn how to build a self-driving car. I'm not taking your valuable time. Let's go for the session. Before that, I would like to introduce our speaker. This is a golden opportunity for all of you to join with him today. When we talk about self-driving car in Sri Lanka, this is a familiar name for all of us. He's Pramadita Aravinda. He's Pramadita Aravinda. He's graduated.
Yes, please go ahead.
Graduated from University of Morto, Bachelor of Science in Engineer with 12-year industry experience, including experience in developing state-of-art robotic proof of concepts for Tier 1 retailer in the US. Currently working as a senior tech lead at Zone 24/7, and he's a world finalist in Imaging Cup 2009 under robotic and algorithms. You can watch this moment. And currently leading a Sri Lankan and US team selected for final round of Big Robotic Challenge Phase 2 conducted by NASA. We wish you all the best to win this competition and make proud Mother Sri Lanka. I hand over to Pramadita to continue the sessions today. Over to you, Pramadita.
Hi, Ravi. Thank you very much for your lovely introduction, and sorry about the mishap. I jumped in prematurely. Let me share my screen and video. I hope you can see my screen now. Let me share video as well.
Go ahead, Pramod.
Okay. You can see me, right?
Yeah.
Okay. If you can see me and all attendees, if you can see my screen as well, please go ahead, type in yes in the chat box. Okay, good. So, are you ready to dive into the future of excited futuristic technology and learn new technologies in a do-it-yourself way? If you are ready, please type in, I am ready. Good, good. Everybody is ready, right? So, when it comes to today's topic, while self-driving cars are still a little bit futuristic technology, and only during last decade or so that these big tech companies like Google, Uber, and Tesla come into the bandwagon of implementing self-driving cars. Actually, this concept was there from a little bit long ago. Now, Nabi, let me ask you a quick question. Can you remember when you first saw a self-driving car or something like that, maybe in a movie or a television?
Oh, yes, Pramadita. When I was little, there is a TV series called Knight Rider. I have seen that car in there. It's a kind of autonomous car. It's a self-driving car actually. I have seen on there.
Yes, you are correct. I think most of our today's audience, those like us, 80s, 90s, and maybe even the new millennial kids, grow up with this familiar vehicle that had so much futuristic technology. Apart from its witty, talkative chatbot and slamming through walls and all of those, one thing that we can remember is that it is capable of driving itself. So that's where we got introduced into these self-driving vehicles. So it may be a science fiction, but it's actually, if we think about what our most of the technologies were defined by science fiction. Now, we have already gone into realization of this technology. Now, Nabi, let me ask you also another question. Can you name a production vehicle or even an announced vehicle that we will see in the near future that it actually have a self-driving capability?
Yeah. What about Tesla Autopilot? What do you think
of course.
Yeah.
So when we talk about self-driving cars, these days what comes into our mind is actually Tesla. So undoubtedly, it's the most. This video doesn't have actually any audio, so don't worry about that. So when it comes to Tesla, it's actually categorized as an advanced ADAS system or ADAS system, Advanced Driver Assistance System. Why it's called Advanced Driver Assistance System? Because even though you see that people leaving the vehicle to drive itself, and sometimes even there is YouTube that claims that people pretend that they are sleeping and vehicle is already self-driving. Actually, by definition, Tesla is only a driver assistance system. So you are actually supposed to be monitoring the vehicle, and if the vehicle is going to be doing something that it's not supposed to do, actually you have to take the decision yourself and take the control back. I will come into more explanation of this driver assistance system so on in a bit. But what we have to remember is that actually Tesla is only an assisting system, not actually fully self-driving capable yet. It may be in near future, but yet it is not a system like that. And this video has sound. Let's see whether it gets shared properly. You can hear audio as well, right? In the background. So another company that have self-driving robot taxi service in public beta state right now. It's very much. This is a sister company of Google. Under the umbrella of Alphabet. So they have internal robot taxi service that you can order self-driving vehicles. Is it good now? If it is good now, okay. Let me reduce the vehicle. Okay. Now you can hear me, right?
Yes, we
If
can
you
hear
can
you.
hear me, right? Okay, good. So I will continue my speech. So the Waymo is a robotaxi service, and it's right now in public beta, and it has the capability that you can order a taxi without a human driver that comes to your place that you ordered the taxi, like Uber or Picnic. And when you jump into the vehicle, there's nobody driving it. It's self-driving to your destination, and you can drop off. Now, this video actually is a marketing video, which is carefully curated to sell the technology. Now, don't get fooled. The actual realization is somewhat lagging. So this is actually from the point of actual rider's point of view. There's a YouTuber that documents his day-to-day experience by public testing this robotaxi service, Waymo service. He claims that he is not paid by Waymo, and we can believe that. He are quite frankly open about the mistakes that the vehicle do. I'm not planning to play the entire video here. It's quite a little bit lengthier. But you can see that I will share the link later that you can see, and you can see that it's actually still in its primitive stage. So actually this is not a fully solved problem, but at the same time there's so much progress and there's so much things that we can do on our own as well. So similar to this, there is another product, an open source product, that even you and me, persons like you and me, can contribute, because that's the beauty of open source projects. So if Tesla and Waymo is Microsoft and Apple of the self-driving car, this Comma AI system that I am showing, which I also have contributed with some vehicle controlling code for Japanese vehicle models. This is the Linux of the way of building self-driving cars. So today I will let you introduce to the basic concepts of building a self-driving vehicle, and you can actually go ahead, learn more, and contribute to the project like this that might redefine the future of self-driving cars.
Okay, Pamadika. So we talk about terms like full self-driving and advanced driving assistance. These are ongoing projects, have various level of achievements. Are there different level of self-driving vehicle? Why you call them most of systems are still in level 2?
Yes, Nabi, that's a good question. So when it comes to the self-driving vehicles, there are a certain level of achievements. So basically from level 0 to level 5. So you may frequently hear that, okay, we are targeting for level 5, we will see level 5 vehicles in, let's say, 3 years in future, 5 years from future. Actually, around 2015, they were claiming that by 2020, we will see level 5, but still we are not there yet. And this is the actual the real life. But we will eventually get there. So let me explain what's meant by level 0, level 1 and level 2, so on. So basically level 0 is there's no automation features. Just your very old plain old car that you have to drive yourself. When it comes to level 1, these cars can handle one task at a time. Let's say like automatic braking, you all know that there are new vehicles fitted with safety features like if your vehicle is going to crash, it's going to apply brake itself and prevent the collision. So it can do only one task at a time. So this is level 1 feature. We have already seen that it's becoming actually standard, this level on newer vehicles. And when it comes to the level 2, these cars would have at least 2 automation features. Say, in vehicle, you have mainly 2 control functions. Either you steer and you apply either brake or accelerator for controlling the speed. You have the control of the speed, you have the control of direction. So in level 2, these vehicles have both these automated functions. So they have the capability of staying in the lane, and they also have capability of acceleration or braking, mainly for the purpose of staying on a set speed or cruise control. I think you are familiar with these terms already because these are becoming standard functions in newer vehicles. So up to this level, the main point is the driver still is responsible. In other words, if say the vehicle is going to do something crazy, like going to crash into a stop vehicle or even a stray animal in the road or a tree in the outside, the vehicle manufacturers are not considering the situation that this system might not work properly. So that's the difference between level 2. So it's the responsibility of the driver to prevent if something that's going to happen still. So when it comes to the level 3, that is the tipping point. So in level 3, the vehicles may not handle all the situations, but vehicles should be capable of telling the driver that there is going to be a situation that I cannot handle. Please come and save me. Okay? So that's the difference between level 2 and level 3. So, driver may take his attention outside, but if the vehicle requests that, okay, you need to pay attention now, he should be ready to pay the attention. But he is not required to pay attention. So now, by definition, now Tesla is going between level 2 and level 3. I mean, by legality, they are claiming that it's in level 2 because of legal reasons. That because you have seen that there are situations that driver is not paying attention and some Tesla vehicles getting into crash because in definition it actually is still level 2. You can't sue the Tesla because they are classifying it as a driver assistance system. So maybe we can consider that Waymo is level 3 because actually there is no person there. But what actually happens is someone remotely monitoring actually the vehicle. So even somebody can claim that it's level 2, it's level 3 because these are not like you pass from grade 2 to grade 3. There is no such hard and fast clear definition between these two. It's up to yourself to define what your level. So, and in level 4, this will be occasionally drivable. So there should be an official announcement that, okay, we have 100% guarantee this vehicle, let's say, work on highways. Okay, on these highways, this can work driverless, no matter what environment conditions and so on. You have to say that under certain conditions, this is driverless, and within that conditions, it should 100% work autonomously without a driver being present. And level 5 is obviously the holy grail of self-driving vehicles. Actually, even these vehicles will not be fitted with steering wheel and pedal and steering wheel and acceleration and brake pedals, because on every possible condition that you can conceive, these vehicles will work autonomously. So there's no need of human presence. So that's the holy grail of self-driving vehicle, the level 5. So up to this point, questions? Yes, go ahead, Nadi.
Another question. We got an idea how to build self-driving car, and it's not easy actually. It's very difficult. So why big technology companies are pumping billions of dollars into these building these driving vehicles? So are there anything other than being just a window for self-driving cars?
Yes, Nadi. Good question. So you may think that this is just a nice technology, that just a gimmick that these self-driving cars. Why don't we get ourselves into a vehicle and drive ourselves? But there's two main points. One is greater road safety. That's actually a very promising thing, because even if we didn't think about that, even in Sri Lanka, you know that every day you can hear about a situation that there is a vehicle crash, actually a fatal crashes. So there are so many crashes that doesn't get people killed, but actually a lot of property damages. So according to a 1985 report, I'm pretty much sure these numbers could go higher with recent vehicles that have that are very reliable and so on, and the road conditions getting better and so on. Even in 1985, about 93% of crashes are either fully or partly to be blamed to the human error or driver error. So people are making mistakes. So this is one thing. So if all the vehicles are self-driving, this will get reduced. I mean, until we achieve the full autonomous and 100% autonomy, which will eventually happen, these numbers might not have a full, perceivable decline, but you see that what's the importance of. And another thing is more productivity. According to another research, even only on US, drivers spend around 75 billion hours annually behind the wheel. So there may be some people that like to actually, when you are going on a road trip, maybe you like to have the experience of driving yourself or so on. But just think about it, even you, day-to-day life, how much of time you are spending behind the wheel driving, that maybe if you had the opportunity, could have spent on something else useful. Because, I mean, day to day, you are driving on the same road, same condition, and traffic conditions and so on. You can't do any productive work, but you have to just keep driving. So these numbers actually gets into the productivity of the entire society. So actually, this is not a $1 million problem. No, this is not a $1 billion problem. Actually, this is a $1 trillion problem, maybe multi-trillion dollar.
Yes, it sounds so cool. How we can contribute to this? I mean, can we really build one for ourselves?
Yes, as I already said, we can take our hands dirty and experience these technologies in a do-it-yourself way and build basic these technologies ourselves, even today.
Great. I'm so excited. But one more question. I do need a car to build self-driving car. I don't think my dad would be so happy to break in our family car. So, what's your opinion?
Yes, I know that. So, what we are going to do is, we all understand that we may not everybody would have a plain old car to make it a self-driving car, and maybe even we may not be willing to tinker with our actual vehicle. So what we are going to do is, we are going to give you a car, literally. So the real question is, would you like to make a self-driving car out of a supercar or Cybertruck? How about Tesla Cybertruck? Now, what we are going to do is, we will be going to give you a simulation environment that you can, there are some people like Cybertruck. So I think most of the people will pick the Cybertruck, but it's up to you to select out of those two. We will give you both options. But I think probably everybody is going to pick the Cybertruck. No problem. We will give everybody a Cybertruck. Don't tell Elon Musk. He will be angry. So the thing is, now these simulation environments are very good starting point to get our hands dirty with this technology, because you don't have to invest on anything. You don't have to be worried about breaking anything. But actually, these simulation environments are very worthwhile, because even big companies like Waymo, Tesla, actually, as their first step, test these technologies on a simulation environment, so that you can prove that it's working okay. Then only you can you would go ahead into the physical environment. So actually, even towards the latter part, I will even introduce you the ways that you can bring this simulation tested code base even into a physical world without breaking anything or investing heavily. So please stay tuned with us, and I will introduce you those systems. So with that, let me briefly go through the session roadmap for today and next week. So in today's session, we already had a little bit of introduction to our session, which already did, and then I will present you the high-level system architecture of a self-driving vehicle, and briefly explain its part, mainly perception and sensor fusion system. Don't get intimidated with these techie terms. I will simply explain what each term means. Then how a self-driving vehicle localize itself or realize its environment itself, and how it's going to plan its next course of actions, which comes under planning and control. Then towards the latter part of today's session, with that simulation environment we will be sharing with you at the end of the session, I will do a live coding demo, kind of a walkthrough fashion, how you can solve one problem of this system, mainly how to keep your vehicle in your lane. I will briefly introduce what you will be learning on next session as well, so that you can keep looking forward. We will also do a deep learning session or end-to-end driving demo on next session. So I think it would be very beneficial for you to have a revisit or revision on our first tech series session, deep learning session, when come into the next session. You can have recorded session if you have missed to attend on that deep learning session. Don't worry. We will reshare that link as well at the end of this session. Then we will now. Today we will discuss about controlling your vehicle laterally. On next session, we are going to introduce you how to control your vehicle on longitudinal or acceleration and braking with sensor inputs. This will be also a live coding session at the beginning on next session. And then doing some path planning. Also, how to handle slow moving vehicles that are in front of you. And then towards the latter part of the next session, we will introduce you how to bring this simulation tested systems into actual vehicles. And we will keep looking. We will have a challenge as well at the end of this 2 sessions. We will introduce you to a coding challenge that you can apply what you learned on these sessions and also win exciting prizes. Please keep looking forward for that as well. So that would be the overall session. So Nadi, if there is any questions that already people have asked, I think we can.
No.
Okay.
No, not yet. We don't have any question from the data.
Okay. If there is questions, please.
One question.
Mm-hmm.
Can I ask you?
Okay.
Are there any simulation softwares cloud-based? One audience.
No.
One question from audience.
This simulation we are going to give you, you can run on your computer itself. There is no need to buy any cloud systems. Actually, if you really want, you can put this in a cloud system, but we are not expecting the participants to buy any cloud systems. And it will not need any special computing hardware like NVIDIA graphics. I mean, there are some simulation software that need NVIDIA graphics card and so on, but don't worry. The simulation system we will give you, does not need any special hardware. It will usually should run without any problem on any decent laptop or desktop computer. And it will have both versions of Windows version and as well as Linux version. So you wouldn't be left out. I think I will have to check whether there is a Mac OS version as well. I believe there is one. So all of the people will be covered, and you should be good to go.
Another question from audience: how to use segmentation in self-driving?
Yes, that is a good question. Within this session, now I haven't planned to do a very detailed demonstration on segmentation, but I will surely introduce some brief introduction on next session. Thanks for raising that point.
Another question: what are the apps we need to download for coding? So we are going to discuss about that on the next session.
Yeah, even today also I will introduce you. Basically, a little bit of Python environment and a little bit of Python knowledge would be beneficial. Apart from having a Python runtime environment, there won't be any necessary other software. We will give you a detailed documentation regarding what Python libraries you need to install. So if you don't have a detailed or advanced Python experience, don't be afraid. It's not too much hard to understand. We will also give you a quick tutorials that you can follow on yourself on your free time to get to a introduction into the Python, just in case you don't have any prior Python coding experience. But it's very easier to follow along and do understand the concepts.
Yeah, you can go ahead.
Okay. Yeah, let's go ahead with the detail. We will keep your questions coming in. We will again have another question and answer session. So, when it comes to a self-driving vehicle, there are major major components of a self-driving car. There are a lot of architectures developed by different companies. Like now, Waymo have their own software stack. Tesla has their own software stack. Uber has their own. Even Uber is trying out self-driving taxi service. And the Chinese search giant, if you have may have heard about Baidu. Baidu has Apollo software structure for self-driving cars. So, but the thing is, when you carefully look into this, actually all these have common set of components that behave similarly. So the first thing is visualizing the environment. So for that, these systems have components that computer vision and sensor fusion. Don't worry about these terms. I will explain in a moment. And once the sensor fusion is done, what the vehicle mainly do is it localize itself or make an understanding where in the earth it is. So that's when it comes to the localization. So when it realizes, okay, I am in this situation and I am in this place, and there are these vehicles that are behaving like this. So once it's done that, then only it can make a future plan, okay, whether to go ahead or whether to make a left turn or right turn. And that is path planning. So it actually has to have a very detailed planning of how hard it is going to turn and how hard it is going to accelerate or brake. So it will make a plan of that. Then it can make the application to the control. So depending on which level of achievement you are targeting, whether you are achieving level 2 or level 5, these systems may have a different level of subcomponents. So in level 2, you don't need to have a very high level planning of from let's say you are going from Chilao to Colombo. You don't have to have a high level plan of going from Chilao to Colombo in level 2 vehicles, because the level 2 vehicles only operate on its local environment. It's only considering about its current lane and next 2 lanes probably, and what's in front of and what's in behind. It doesn't think about whether I am in actually in Chilao or Nigambo zone. So, but when it's to level 5, you have to actually have to plan from point A to point B entirely. So, depending on that, this path planning module will have a different level of subcomponents in these modules. So, here is a fully detailed overview of this is actually the software architecture of that Apollo system I introduced you in a overview or higher level description. There you can see that it has some additional components like predicting its next to the neighbor vehicles, and it also needs to have access to high definition maps like in very detail where it is actually is in the road and so on, and like that. So let me now take each subsystem separately and give a higher level introduction to you. The first set of modules is perception and sensor fusion modules. So when it comes to perception, you can understand them. It's basically what sensor components that you would be using to perceive the environment of the vehicle. So there are different types of self-driving sensors, mainly cameras and radars and LiDAR. So camera are basically normal computer vision cameras that you would put in around your vehicle. Radar also should be a familiar term to you. It's the way of detecting obstacles in the environment by sending out radio waves and measuring the time it takes to hear the echo. So you should be familiar with weather radars and air traffic control radars and so on. So similarly like that, there is radar sensors that can be installed on vehicles. So even some auto braking vehicles operate by using a radar to detect obstacles in the environment. Now, when it comes to the LiDAR, some of you may have already heard this term if you are familiar with building robots, because LiDAR is a very popular sensor with advanced robots building. The difference between LiDAR and radar is both of these sensors are doing this actually same function, but the difference is what kind of wave it used to detect the distance. So in radar, it's radio waves. It sends radio waves and measure the time for the radio wave to go hit an obstacle and come back. When it comes to the LiDAR, what it uses light waves or light pulses. So what it does is sends out the light pulse and measure the time it takes to come back the echo. So the difference is in radar, the radio waves get scattered or go out of its path slightly when a radio wave propagates. But if you have a laser beam or light wave, it's straight. It doesn't go stray or scatter around the environment much. So LiDARs can have higher resolution than radar. But at the same time, LiDAR is very expensive. So around a couple of years ago, let me tell you a brief backstory on the self-driving community. So around 2016 or 17, these Waymo and other companies were heavily relying on LiDAR as well as the other sensors as well, of course. But Tesla decided that, okay, we are not going to use LiDAR. The main reason was, at that point, a LiDAR suit would cost almost couple of times the cost of a vehicle. So let's say if a vehicle is 50 lakhs, the LiDAR set will be around 200 lakhs. So that's the main reason that Tesla decided that at that point it's not economical to introduce LiDAR. But the other companies believed that the LiDAR will eventually, the cost will be reduced. So I recently read the article that explained that actually right now actually LiDAR prices have gone down. Now a few years ago a high definition 3D LiDAR would cost almost like 50 lakhs or so. But right now there are some 3D LiDAR sensors with comparable capability that coming under 100,000 rupees or $1,000 also. So you can see that what has happened in the recent past. And actually I heard that Tesla now testing out with some Lumina LiDAR sensors, which is Lumina is a company that's building 3D LiDAR. So the importance here is, as I have shown, these green dots means a good point, and red cross is not a good point, and half yellow mark is in between. So when it comes to the cost, cameras are very cheap, LiDAR are very expensive, and radar is in between. Not too expensive, because even in recent vehicles they can introduce radar components without much price. Likewise, when it comes to different points, it has different advantages on different sensors. There is no single sensor that has all the good features. So what you do is you take a sensor set that complement the good features of each other. So by using multiple types of sensors, it can have all the good features in all. So other than using a single type of sensor, by combining inputs from multiple sensors. So one sensor may not be able to have all the good features, but combining the features of different sensors, you can have a good picture of the environment. That's what called the sensor fusion. So let me again introduce you what each symbol in this table means. Sorry, I have missed the legend in the system. So green dot means it's good. So from cost-wise perspective, camera is good. But from cost-wise perspective, LiDAR is not good. And from cost-wise perspective, radar is in between. It's not too much costly, or it's not too much cheap as well, but it's manageable. So likewise, illumination. So when it goes dark, your camera doesn't going to work because cameras can't see in the dark. If you have infrared cameras, it may somewhat work, but cameras need artificial illumination. And when it comes to LiDAR and radar, you don't need any illumination. Now you get the picture, right? And from the noise perspective, actually camera has a very good quality camera, have less noise. I mean, it's very clear. I mean, you can figure out whether it is a human or a tree or a dog from input. But when it comes to LiDAR and radar, they have somewhat noise. So even in LiDAR and radar, let's say you measure a distance to be 50 meters, but there would be a plus or minus error. Likewise. So from range perspective, it is properly illuminated. You have a good range in camera. So you can see miles of distance with the camera. But radar and LiDAR both have a limited range, like 100 meters or so. So likewise, I have given this as a reference for you to understand what's the difference between each sensors and the importance of sensor fusion. When it comes to the when it perceives its environment, a self-driving vehicle then needs to localize itself in the environment where it is. So that's where it called localization. Now, when we tell localization, measuring the point where it is in the environment, what would be your first thought? I mean, right now, when you have a mobile phone, what would be you would be using to figure out where you are? So, please go ahead and type in a couple of answers that you can think of. basically with the mobile phone, what sensor you would be using. Actually, Google Map is the product. So actually, what sensor you would be using? Yes, GPS. Now you may think, can't we use GPS for localization on a self-driving car? Actually, no. You can use it as a input, but not entirely. The problem is with GPS, your accuracy in most cases would be a couple of meters. Now you realize what's the problem. Now, in a situation like this, if your sensor has an error of around 3 meters, you could be either here or here. I mean, you are already maybe either on the side lane that has the turn, or maybe you are already on this lane still. And if you realize that now if you take the turn, you are going to go over the sidewalk. So that's the problem of not using GPS entirely on its own. So again, you need to have a fusion with other sensors like LiDAR and radar sensors. Mainly you would be using 3D LiDAR to perceive the environment features like trees, buildings, and so on, and measuring the distance and combining that information with GPS, only you would be able to fully localize your self-driving car into accuracy like few centimeters. At least you need to have less than 1 feet of accuracy. When it comes to system like level 2, you don't have to be worry about entire localization. You only have to be aware of which lane I am in and how far away the next vehicle and so on. Whether I am in the middle of the lane or towards the side of the lane, because we are just keeping a smaller view of the environment, because we are only solving a smaller problem. We are just solving the local problem, not a very global view of problem in level 2, but you can think that it's still localization. You are still figuring out with respect to your local environment where I am. And when you have solved that problem, you can have planning and control. So you can plan what you are going to take your next action. Are you going to stay on your own lane, or are you going to move into the next lane and move ahead across the by passing your slow moving next vehicle and so on. That's basically what's planning and control. When you combine all these systems together, you can build in a self-driving car. Now, if there is a couple of more questions, I think we can answer them.
Yes, Prabhadita, we have some question. One question from audience. Can we train self-driving car using reinforcement learning?
Yes, you can. While I will not be including it as a live demo, live coding demo, I will point out for some resources that you can study on your own, and even use this same simulation environment we will be giving out to try out reinforcement learning on themselves. And by doing that, they can actually try it out in building a actual physical test as well, if they want. But usually in reinforcement learning, you usually play with a simulation environment. You don't do reinforcement learning with actual vehicles, because the basic perspective or basic idea of reinforcement learning is learn by mistakes. So you let it to do mistakes and understand its mistake and improve itself. So you can simply understand that you can't do that in a physical system, because then your vehicle is going to do nasty mistakes and wreak havoc on the environment. So yes, you can use the same simulation environment. It's actually even used for reinforcement learning. Yes, you can use it.
Another question. You have any self-driving app and a learner system, sir?
Can you please repeat the question?
One question from audience. Do you have any self-driving app or learner system? Self-driving app or learner system? I don't have an idea what he's asking about. He's asking about self-driving app or learner system. I think it's not clear. Let's move to another question. Could we get...
I believe the participant is asking, you have any self-driving app and learn a system? Probably I am not entirely understanding the question, but if the participant can rephrase it, we can have a retry it. I'm not sure whether he is asking about a kind of a course or something as a suggestion. In that case, there is a couple of courses that we can point out as resources at the end of the session on the WhatsApp group. Some are free, some are paid courses. If that was the question he was asking. Please go ahead with the other question.
Yes, another question. Can we get a knowledge of making our own hardware and write a program for it?
Can you please come again?
Can we get the knowledge of making their own hardware and write a program for it? I think he's asking about can we build our own self-driving car kind of thing.
Yes, I mean will be different level. I can point out to resources that they can study on their own, and one thing is definitely this system I am pointing out, and the results directly can be applied to even a toy car, and there's no problem in doing that. If there is some audiences that are planning to go ahead with building actual systems with real vehicles, there are some resources, but basically you also have to be responsible and ethical of what you would be doing. But certainly sky is the limit, but you can actually build a real system as well. Maybe I think some audience could be from university students. So even solving a problem like this is a good advice for final year project or so on. That would definitely be good for your academic portfolio. So I believe that I answered that question sufficiently.
Yes, Pramod. Next question. Can we do distance tracking with using 2 or multiple cameras?
Yes, from stereo cameras or multiple cameras, you can measure the distance. But the thing is, raw distance measurement from multiple cameras might have somewhat inferior results than using something like LiDAR. So with LiDAR, the error doesn't have much get much higher for the full range of measurement. But when you use stereo cameras, there is a certain range, not too near, not too far. There is a certain range of obstacles only you can measure with good result. So it's definitely doable, but there is some situations that using a sensor like LiDAR would be better. But yes, you can measure distance with stereo camera.
Another question. Can we get the knowledge of making own hardware and write a program for it?
I think I at least partially or fully answered that question while answering that you can build a physical system, I mean apply this in physical situation as well. There will be some additional knowledge that you need to be gathering separately, like when it comes to a actual physical system, depending on, let's say if you have a toy car, you will have to figure out yourself what communication protocol or serial communication protocol its controller board would be using, and so on. That would depend on what toy car you would be using. In case of a physical vehicle, they are usually used by control area network control mechanism, or called CAD. That also depend on different vehicle manufacturers. So some information are not publicly available. Some are publicly available. That depends on. So I think it's better if these attendees have any particular use cases, separately contact with their use case and what they are looking for. So in that case, it will be more easier to answer case by case separately.
Yes, another question. Can we change the car to manual when it's auto self-driving system?
I believe this is asking for not for the system that we are building, but in perspective of actual self-driving vehicles in the market. So at the current point of implementation, it's even legally required to be able to take the control manually on current situations, because in level 2, it's definitely required that driver need to be able to take control manually. On level 5, the system should be completely demonstrated that under any conditions it's safe to operate and it's not going to crash to anything. And even its cyber security system is strong enough that no hacker will take control of that and so on. That's why level 5 is very difficult. So in that case, it may not be physically possible, but even in this case, the laws will require that there should be some button or remote system that capable of at least disabling the system. So up until then, it's always should come under manual control if somebody is requesting manual. Yes, these systems should always be capable of taking manual.
Yes, Pramadita, it's another question. If the sensors, radar, lidar, whatever, if it's get dead, could it cause for an accident? Then what are the techniques to keep the components always dead free?
It's handled differently in different levels. So the thing is, your software system should be self-diagnosing. So like in level 2 kind of situation, let's get. So in that case, system should refuse to get activated if it's sensing that sensor is dead. So in level 2, it's not a problem if system did not get deactivated itself because of a dirty sensor, because still the driver should take the responsibility of understanding that the system is not functioning properly and behaving erratically. In level 3 and so on, the system should indicate that the sensor is not working properly, and so that I cannot get activated. So it should not usually cause an accident. The system design should be capable of handling such situations. But it is a real possibility that if you miss to take that safety precautions, yes, getting a sensor dirty could end up in an accident. So it's our responsibility as self-driving car technology implementers to take necessary safety precautions to handle the situations where sensor is dirty.
There are a lot of questions from the audience.
And yeah, go ahead.
Normally we start at the country driving classes. So one question from driving class. Teachers ask you like automatic or manual. Which one is the best for future?
This is not directly related to the
no, it's not.
But
yeah.
Probably in future, this is just my personal opinion. Probably in future, most of the vehicles might be auto gear vehicles, but there will be always the manual vehicles, I believe, even without self-driving technologies, because even still yet, there are some people that believe in the pressure of driving manuals. But majority will be automatic, and probably in future, while we are in level 2 or level 3 stage, especially in level 3 self-driving stage, probably there will be driving license that are only that you can use for semi-autonomous vehicles or level 3 self-driving vehicles. So you are actually not very capable of handling all the driving situations. You are just there for bringing the vehicle for safety, like in case of a self-driving car, and you are not allowed to drive a manual driving car. There could be situations. This is just my personal opinion, but there could be situations like that.
Yeah, and another question. Computer vision-based perception methods significantly more computationally exhausted than radar lidar.
Yes, computer vision from some algorithms in computer vision is a little bit computationally exhaustive for cameras. With LiDAR and radar, especially now when it comes to radar, the sensor itself is capable of measuring the velocity of the other vehicles. So you don't have to calculate the velocity. But when it comes to LiDAR, it doesn't emit velocity of the other vehicles. It can only perceive other vehicles. You have to calculate the velocity yourself by taking two adjacent measurement and figuring out, okay, this measurement in this time and this measurement in this time refers to the same vehicle, and so you can calculate the velocity. And with cameras, you don't even get the distance. You have to first calculate the distance and so on. So with computer vision, it's a bit exhaustive, but at the same time, they are building specialized hardware, which is called application specific IC, ASIC, kind of chips that's built using microcontroller technologies that are dedicated for computer vision purposes. So once you use those components, probably your main self-driving hardware, self-driving software algorithm might be able to run on the same set of normal hardware. Depends.
Another question. What will happen if the system will get hacked?
That's a problem for a cybersecurity expert. I think you are familiar with situations where then happens. Like I think in Fast and Furious 7, right? If you have seen the movie, what could happen if a self-driving vehicles were commandeered maliciously? This is actually not a problem specific to the self-driving vehicles. That's a general problem in all the systems that has a computer. So that is also a point that you need to think of. Because the thing is, one thing is up to now, these vehicles were usually, the computers in the vehicles were isolated environment. They don't communicate with the outside worlds and so on. But increasingly they are connected to the internet. So what you usually do is place a gateway component in the internet, but as you know, all the systems might have attack vectors, so loopholes to attackers to get into. So it's just a cat and mouse play between good guys and bad guys.
Another question. Is there any software available in the market, electrical circuits and test it visually? Give me some names of the systems.
Can you please come again?
Is there any software available in the market to test electrical circuit visually? Give me some name of these systems.
I would pass that questions into the probably in the WhatsApp group, because it's not directly related to self-driving vehicles, but in a general question for electrical circuit design, I'm pretty sure there are better people in the community able to answer questions, general questions like this.
Yeah, you can go ahead, Pramudita.
Okay, let's go ahead with the simulation demo. Probably I try to complete the live coding demo today for the lateral control. If we couldn't finish completely, we will quickly finish it on next session. But at the end, we will have a very brief question and answer session if there is any additional questions. So this simulator has its own client library that you can use to control. Let me quickly get it. Okay. Probably, if you might have even some of you have come across, but don't worry if you're already familiar. But for the benefit of the majority of the attendees, this is an open source simulator that I am using. Actually, it's called Donkey Car, because there is a project called Donkey Car for creating a kind of toy car from basic components that they even use for kind of small competitions, and we are using the same components. Let me quickly test system. Did you lose my screen sharing?
No, we can see you and we can hear you properly.
Okay, you should continuously have my voice. Didn't know that. Yes, I got.
It's pretty good. It's pretty good, Pramudita. We can hear you.
Okay. But I got a pop-up message that I lost my screen sharing.
Oh, we can leave it.
Still, you can hear. See,
yeah,
right?
Yeah.
So don't worry too much about the actual code. If the font size is legible and readable, if not, I can increase size a little bit. So let me try launching the test environment. You should see the simulator launching and a small toy car getting spawned and driving straight. If you can see it, type in yes on the chat.
Yes, we can see you.
Okay, that's so. In that code, it's actually not applying any steering control, and I have applied the small steering value. Now let's take, in this observation is the camera value. Let's try taking that camera pictures and saving a couple of items.
Prabhudita, can you please explain about this software? One question
Yes.
from audience.
So,
they are asking.
This is actually a small software developed using Unity framework. Actually, you can even run it manually as well. We will share this software with all the audience, pre-built one. It has a couple of inbuilt tracks you can play around. This is my favorite track that I usually use. You can even manually drive it around. But what I am actually using is there is a client library called Jim Donkey Car. By importing that and setting some configuration values, we will provide the links to documentation materials that explains each of these configuration schemes. Usually you don't have to worry too much, but if you want to play around and change the appearance of the vehicle and so on, you are free to go ahead and change it. The main thing happen is in this for loop. What happens is first it resets the environment. So place the vehicle on the starting line, and in the while loop, what you do is you take action or calculate action and apply that action and simulate a small time step, say 1/10 of a second, and then you get the observations or camera image, and then you calculate the next action and you apply it again. So that's the basic idea of using this simulation. So on top of that, now what I am going to do is try to capture some images and save it and see what the this self-driving vehicle is actually seeing in the environment. Let us try that. So it started the simulator and run the simulator for a very brief time because I don't need a lot of camera images. So what I did was, for the time step, I am saving what the camera is seeing into a file. So it should be in the test images folder. Sorry, I forgot to create the folder. It doesn't create the folder itself. Let me try it again. By the way, can you see the text in that code editor? Or is it too small?
What text, Pramudita?
Can you see this code
Yes.
in this
Yes, we can
editor,
see
or
it.
is it too small?
No,
You
it's
can see
okay.
it,
We
right?
can read it.
Because I was explaining what this code is doing in a high level. I might not be able to explain each and everything in very detail, but definitely we provide documentation materials that comes with this software that you can study on your free time. Let's see whether we got the images. Yeah, we got the images saved, but I think there is a problem that color is not properly. Yeah, I see the problem. So the thing is, the people familiar with computer vision might know that some systems save the color images in RGB order, red, green, blue order, while some systems store colors in the opposite order, BGR, blue, green, red order. So in that case, we need to rectify it. Let me quickly rectify it.
Pramudita, one request from the audience. Can we make that there will be big letters?
Please come again.
If you make it a little bit bigger, they will read it very clearly.
The text, right?
Yeah.
Okay. Let me check. Is it now good?
Yes. It's visible for me, but I don't know what about the audience. You can ask that question from the audience. Yeah, they're mentioning as visible.
Now it's good, right? Okay.
Yes.
Let me check the images again. Now the color is good. Now let me pull some code of my own from a little bit of past that we can readily use. So now what I am going to try is from this image extract the color pixels only belong to the lane lines. So once I have the extract only the lane lines and declutter the environment of about, because I am not caring about the trees, beautiful sky, that doesn't play much of a role in keeping on our lane. What we are really interested is about the lane marking. So what now I am trying to do is extract the lane marking. I think I have a project or exercise that was done on that. Let me quickly steal from myself some code that I can use. I will share this my project as well, that you can use for your own purposes as well. No problem. I think I have released it under MIT license, so you are free to modify it for your own purposes if you want. No problem in that. Let me quickly pull a couple of things, and I think there is Jupyter Notebook. You may be familiar with using Python notebooks in that deep learning session. So they are a good way to keep notes on what you have tried and what are the results and so on. Kind of an interactive notebook kind of thing. Let me get that as well. And try it out there. I think it's still downloading. Bear with me, I think connection is a little bit slower. Okay, I got it. Okay, in this project, there is some camera calibration that you need to do in a real camera if you are using. So basically this would be beneficial if we are moving from simulation to actual physical cameras, because physical cameras will have some distortion in the image. But in our simulation camera, we don't have any distortions in the picture. So I am going to remove things that are not needed for our thing. I will keep the imports, and then I don't need this as well. And I don't need to undistort the system. So I'm removing that as well. But since the code in the below section, I will simply use the image itself. So what I did was load the images and test it. Then this doesn't need. We will share the partially completed live coding session files as well with the audience so that they can see what's the final result. Then here are some image processing pipeline.
Pramodito, we cannot hear you. Pramodito, can you hear me?
You have been kicked from this conference.
Okay, can you all hear me now?
Yes, we can hear you.
If you can all hear me now, please go ahead and type yes on the chat. Okay, good. Sorry about the mishap. Right, so what I was describing was, here are some of image processing procedures that you can use to pick colors of certain colors like white and yellow and so on. You can go ahead and read I'm basically using OpenCV software library for image processing. Those who are familiar with image processing might have already familiar with this library. If not, you can go ahead and read the documentation we will be sharing on your free time for further details. And let's try processing one of our images through that image processing pipeline and see whether we can extract the lane lines from one of our images. Right. Okay, results is not too bad. It has somewhat selected the lane lines, but it also at the same time missed some of the pixels on the image, it inevitably select the crossing line as well. I will not be doing full fine tuning of this line right now, but you can play around with these threshold levels, and basically on the challenge you will need to play around with these levels and get a good results of extracting lane lines properly. So I will leave it at this point. Now, if everybody is okay, we can have a couple of more time, probably 10 minutes or so. So that we can finish up what we picked today. Okay, good. So let me get this now, since this I tested this in the sandbox environment of Python notebook. Let me get the necessary codes to my main procedure function. Yes, at the end of this session, I will be sharing the modified code as well on a separate GitHub repository. Actually, I pulled in this code itself from my public GitHub repository that you already can go ahead and take. And as I mentioned, this is released under MIT license that you can reuse it for any purpose you would like. So basically that's free from me. Let me take this code to here. We don't have to copy paste all the code here, because if we take the Python codes from that repo, we can use it as a library. We need pipeline as well. I have taken note already. Agent pipeline, and we need another call tracker. It's a line tracking algorithm. Let me show how it's also working. On the Python notebook. Now, then what we do is, what we need to do is, now when we take a picture of the environment or road, the lane lines are not perpendicular to each other. They are like meeting on the horizon line. So what we need to do is we need to take a picture like we were taking it from the sky or bird's eye view. To do that, we need to transform this image and make it flattened view. It is called perspective transformation. So basically what we need to do is we take 4 points on a perfect rectangle from this image and transform that into another view. So if we take this image, let me open it in Paint so that we can see its coordinates. And let me increase its size. Now, if you see here, you can see that the vehicle is little bit to the one side, but we can select, like, let's say this side of this line and inner side of this line. So outside of yellow line and inner side of white line appear to be similar distance to each other, assuming that we are at the beginning perfectly aligning with the road. So let me record this values. So one coordinate will be 0 by 111. The other one would be 50 by 69, and so on. 110 by 69 and 159 by 111. So we need to apply those values for the perspective transformation. So source points would be the real coordinates of this rectangle. So it was 0 by 111 and I think 49 by 69. And other one was 111 by 69. Sorry. The last one would be 159 if I remember. Yes. And then you need to pretend that it would be in a you need to transform it to a rectangle like this. So we can just pick some coordinates. Let's use like 30. And for the y coordinates, we can use almost similar values, but you can adjust it actually. And since I offset from x side around 30, from the right side also we can reduce 30 from 159, that would be 129 and 69. Now we can check the result. Oops, sorry. We don't have the output images folder. We don't need it. Okay. Yeah, I think I have picked. The thing is, again, it's jumbling the color. But anyway, you get the idea, right? So this is the normal view. This is the transform view. Now you can see that the road markings are approximately perpendicular. Even in this case, you can see that the lane lines are working properly. So probably I think it's since we are sharing this code session, I believe that it's better to wind up for today and let the audience to try out their own. So basically what we are going to do is the rest of the code is about picking up these two lines and calculating function that represent these two lines. Basically, it's easier to follow along with this Python notebook themselves. And once you have that equation, that would give you what is the offset of the vehicle. I will briefly touch upon once you have the error in the lane, or the how much far away left or far away right on the lane, how to apply that information in a control module to control the vehicle. I will briefly skip to that, but I will definitely share the completed IronPython, the Jupyter notebook, so that people can try their own to get to this result. So let me introduce you to another code repository that will control the vehicle when it has the error in the lane. Okay. And the people would then be able to, the attendees would be able to publish their results on the WhatsApp group. you are welcome to create videos and share. Let me go to control part of the vehicle. From image processing, when we get the lane error or cross-track error, we can use a PID loop to, I will remove this unneeded code segment. And get this away from here. And let me import since we didn't finish taking the image processing and calculating cross-track error ourselves, we will use a debug feature on this on this info section. There is the measurement of raw cross-track error, or how far away in the left or right of the lane. So let us substitute for the now that. When you apply values for the steering, it might be going overshoot of -1 and +1. So you have to clip to the correct value. Let's assume this this has to be actually actually this will give the center line. So let me reduce half of the lane width. And we can apply that. Let us do a quick test. I haven't saved it. Okay, let's hope it's work. Okay, it seems to work, but seems like it's not properly tuned. So now when you comes with the control algorithm,
We cannot hear you, Pramadita.
along with this project, there is some documentation regarding how you can properly tune this. Are you all still with me, or my voice is breaking or some problem?
No, it's fine.
That's great. So let's wind up from here for today. And I will definitely share all the materials and the documentation files with the audience on the WhatsApp group, so that they also can try out this on their own time and come ready for the next session on next week. We will have a brief recap on this as well on the starting of next week. And if there are any other questions remaining, we can answer them now.
No questions from the audience.
Okay, if they have anything more comes in, they can. They are free to mention in the WhatsApp group. I might not be always hanging around in the WhatsApp group, but I will do my best to answer any questions that needs my direct answers. And I would invite the audience as a community to answer their peers' questions if anybody is already familiar with these technologies. So thank you very much. Hope you would be able to gain the dip your toes in the waters of self-driving vehicles, and stay with us for another exciting session. And over to you, Nadi.
Yeah, before wind up the session, I have some information to provide you. Keep in touch with the Makerspace FB page. This session is powered by American Center Colombo. You can visit those FB pages and follow them. And be really grateful about today's session. Thank you very much, Mr. Pramodita Aravinda. This session was really exciting and really amazing. Thank you very much for that. Another thing.
You're welcome.
Actually, I have to give you one information before wind up session. So I have shared with you some links with you from our previous sessions. You can go to YouTube and read them. So okay, I'm going to wind up today's session, and thank you very much for all of you for attending the session. Thank you.